In this section, we begin our study of sequences and series, in particular, infinite sequences. So, when we studied functions, functions had a specific notation. We say f of x. F of x equals some function like 2x plus 3. When we're dealing with sequences, the notation that represents a sequence is a sub n. So a sub n represents a sequence, right? And so a sub n, it represents a sequence, which is an ordered list of numbers. So there will be a sub 1, a sub 2, a sub 3, this should be an a sub 4, all the way up to a sub n. Each one of these is referred to as the term of the sequence. I'm going to kind of skip around here a little bit. So a sub 1 is a term, a sub 2 is a term of the sequence, a sub 3 is a term of the sequence. And the subscript is what we refer to as the index. So the number 1, the number 2, the number 3, the number 4, all the way up to n, that is referred to as the index variable, which is the subscript of the sequence. So a sequence is simply an ordered list of numbers. So as an example, I could have 1, 2, 3, 4, all the way up to n, whatever n is. It could be 1,000, it could be 1,000,000, it could be 10. So that is an ordered listing of numbers. That's all a sequence is. It's just an ordered list of numbers. Now, sometimes we want to write a sequence as a formula. Instead of just writing it as an ordered list of numbers, we want to write it in a formula, like we would write a function as a formula. And so a sub n, which represents our sequence, this would be the formula for the sequence. Now, what that means exactly is that when we usually start with a sub 1, we let n be equal to 1. And so when n is equal to 1, we would have 2/3 to the first power, which is 2/3. When n is 2, we would have a sub 2, so we would have 2/3 to the second power, which would be 4/9. When n is 3, we would have 2/3 to the third power. Whoops, it's getting kind of messy. 2/3 to the third power, which would be 8/27. So my listing of numbers would be 2/3, 4/9, and 8/27. Right? And then we would just keep going as far as we wanted to go. So that is my sequence, a sub n, written out as an ordered list of numbers. And then here we have it written as a formula, an explicit formula. And so you're going to see a lot of that here very shortly. A recurrence relation is a sequence where subsequent terms are defined in terms of the previous terms. So a sub n is any given term. A sub n minus 1 would be the term before it. So in other words, if n is 3, a sub 3 would be the third term. A sub n minus 1 would be the 3 minus 1, or the second term. And this is simply says we're taking the previous term and we're multiplying it by 4. And that would give us our explicit formula, but it's always in terms of the previous term. So that's called a recurrence relation. Another common type of sequence that you will see is an arithmetic sequence. And the key to understanding if something is arithmetic is if the difference between each term is constant. So in this example of a sub n, We have 2, 4, 6, 8, 10. The difference between each term is 2. So we have a constant difference between each term. That makes it arithmetic. A geometric sequence, the ratio between the terms is a constant. The ratio between the terms is a constant. So if we were to take any two successive terms, like here we have 1/2 and 1/4. If we were to take 1/4 and divide it by 1/2, we would have 1/4 divided by 1/2, or times 2 over 1, which would be 1/2. So the difference between these two terms is 1/2. If you take any two terms, you take 1/8 divided by 1/4, 1/16 divided by 1/8. You're going to get the same ratio. You're going to get the same ratio of 1 over 2. Just to see that that's true, go ahead and try it. I don't really have a lot of room right here to do that, but take 1/16 and divide it by 1/8. So that's 1/16 times 8 over 1, which is 8 over 16, which is 1/2. So you have a constant difference, a constant ratio between each terms. If you have that constant ratio between each term, you have a geometric sequence. So it's important to be able to see an arithmetic sequence and the difference between a geometric sequence, two common sequences that we use frequently. Okay, now this is where it gets kind of fun. So in exercise 1, what we want to do is for each of the following sequences, find an explicit formula for the nth term of the sequence. So I've written the explicit formula here, but the question is, how do you get that? And I'll tell you, it's a lot of trial and error. There are certain key things that I'm going to show you that you look for, but a lot of times it's just trial and error. Sometimes it comes to you quickly, sometimes it does not. So one thing that you want to look for is the fact that we have alternating negative signs. So the first term is negative, the third term is negative, the fifth term is negative. Every odd term is negative. This is called an alternating series, and we'll be working with these more. This is an alternating series, means it alternates from positive to negative. Now, if the odd numbered terms are negative, you're going to have a factor of -1 to the n. And so let's just see how that works. When you let n be equal to 1, you have -1 to the first. Well, that's just equal to -1. -1 squared is a +1. -1 to the third is -1. -1 to the fourth is +1. Right? So you can see, starting with n equals 1, we have a negative, then a positive, then a negative, and a positive. And we usually start n with 1. So that's what we want. We want the first, the third, the fifth, every odd term to be negative. So this is the first part of our formula. Now, as far as the rest of it goes, what I like to do is take a look at the numerator and take a look at the denominator separately. So remember, we're going to be starting with a sub 1 when n is equal to 1. So the first term, we got the negative part, but notice that the numerator is a 1. In the second term, the numerator is a 2, a 3, a 4, and a 5. So in each case, the numerator corresponds to the index, right? So a sub 1, the numerator is 1. A sub 2, the numerator is 2. A sub 3, the numerator is 3. A sub 4, the numerator is 4, on and on and on. So the numerator corresponds to the index, or the n value. So that's the second part of our formula. We got the first part, the second part. Now what about the denominator? Well, the denominator is similar. Notice that in every denominator, it's 1 more than n. When n is 1, the denominator is 2. When n is 2, the denominator is 3. So the denominator is simply going to have an n plus 1. All right, so this is our this is our explicit formula for this particular series. So there's two ways to write a series, right? You can write out all of the terms of the series, which is what we did here, or some of the terms, usually the first 3 or 4 terms, and you can write the sequence as a formula. And so you can see that if you let n be equal to 1 here, a sub 1, we're going to have negative 1 to the 1 times 1 all over 1 plus 1, which is a negative 1 over 2, or negative 1/2. And that's our first term of the sequence. And so you do that for each term. You do a sub 2, and you're going to get 2/3. A sub 3, you'll get negative 3/4, etc., etc. All right, let's take a look at the next one. This one's a little more challenging. And this one, again, I want to look at the numerator and the denominator. And I gave you the answer here already, of course, to take a look at. Now, when n is equal to, and again, we're going to take a look at the numerator and denominator separately. So when we look at n equals 1, we have 3 over 4. So the numerator is 3. And then we have a numerator of 9, 27, 81. And what I notice with those is that those are all powers of 3. 3 to the first is 3, 3 to the second is 9, 3 to the third is 27, etc., etc. So what I'm deducing there is when n is equal to 1, we would get 3. When n is equal to 2, we would get 9. So the numerator is simply 3 to the n. 3 to the first is 3, 3 to the second is 9, 3 to the third is 27, ... And those are our numerators. Now the denominator, I'll have to admit, you sometimes just have to play with it. So to look at the first one, the first denominator is a 4. So when n is equal to 1, how would you get a 4? That's the question you want to say. When n is equal to 1, how could you get a 4? Well, maybe you could multiply 4 times n, and you would get a 4 in the first denominator, right? But it's not going to work in the second denominator, all right? You get 4 times 1 is 4, but this is when n equals 1, but when n is equal to 2, you get 4 times 2 is 8, and that's not the second denominator. So this is not going to work. And so sometimes you just have to play around with it, but here's one key. Notice that the denominator is in itself an arithmetic sequence. 4, 7, 10, 13, 16, they all have a common difference of 3. So the denominator itself, just looking at the denominator, is an arithmetic sequences. Now, arithmetic sequences are always expressed as some form of a linear equation. A linear equation, a(n plus b). A and b are just some constants. And so in this case, we have 3n plus 1. 3n plus 1 is the arithmetic sequence that will give us these denominators. So once you know it's an arithmetic sequence, you just kind of start playing around with some a's and b's to make that arithmetic sequence work. Now the first thing I tried was a sub n. I tried multiplying n by 4. Remember, I did 4 times n. We saw that didn't work. So I figured I had to have some kind of a b on there. All right, so that's that one. Now, recursive. So recursives are sometimes a little trickier to play with, and sometimes you just have to. Sometimes you have to actually write out the terms of the sequence. So in a recursive, they always give you a sub 1. So the first term of the sequence is 2. Now the second term of the sequence, a sub n, if n is equal to 2, so a sub 2 would be equal to negative 3 times a sub n minus 1, or negative 3 a sub 1. Well, a sub 1 is 2, so a sub 2 is negative 3 times 2, or negative 6. A sub 3 is going to be negative 3 times negative 6, the term before it, which would be a positive 18. And so our terms kind of go like that. And so we have alternating terms, and so that we have a negative 3 raised to a power. That's going to give us the alternating terms here. And so how do you figure this out? The easiest way is sometimes just start with a sub 1. And if you took a sub 1 and you multiplied it by some other term, could you get that second term? Again, these are a little bit of trial and error. There's just no easy way to really look at these things. The next one is recursive also. A sub 1 is 1/2, and then a sub n is a sub n. A sub n is equal to a sub n minus 1 plus 1/2 to the n power. So a sub 2 is going to be equal to a sub n minus 1, which would be 1/2, plus 1/2 to the second power. So this is 1/2 plus 1/4, which is 3/4. So the second term is 3/4. And then the third term is going to be what? That's third term is going to be a sub n minus 1, which would be 3/4. Let me erase some of this. So a sub 3 is going to be the term before it, 3/4, plus 1/2 to the third power. 1/2 to the third power is 1/8. So 3/4 plus 1/8 is what? 7. 3/4 is going to be 6/8 plus 1/8 is 7/8. All right, so the denominators. Let's just take a look at the denominator. In this case, I notice that the denominators are all powers of 2, right? 2 is 2 to the first, 4 is 2 to the second, 8 is 2 cubed. And so the denominator, in this case, isn't too bad. It's just 2 to the n, 2 to the nth power. But then notice that the numerator are all 1 less than the denominator. 1 is 1 less than 2, 3 is 1 less than 4, 7 is 1 less than 8. So the easiest way to do this is just take the denominator and subtract 1 from it. So again, there's no easy way to do these. You just have to kind of do a few. You develop these tricks. So some of the tricks are, you're going to have either a negative 1 to some power or some number to some power to end up with an alternating series. Take a look at the numerator, take a look at the denominator separately, see if there is some type of an arithmetic pattern to them, see if there's some raised to a power of n, and these just take a little bit of practice. And I believe that is going to be it for this first video. All right, see you in the next one.